Now that we've got LDAP set up on both the primary and secondary systems, let's go ahead and use LDAP Search, one of the online utilities provided with the OpenLDAP suite, to confirm that the records that exist on the primary exists on the secondary. Once we've confirmed the records are in both places, we'll then configure our Solaris server as a secondary or as a tertiary LDAP system. So let's navigate to our notes, and we'll label this section Confirm LDAP Records on Primary and Secondary Systems. Again, just to refresh our memories here, back to our graph of the directory information tree. Thus far we've built only a fraction of the DIT, including the root or base DN, DC equals Linux CBT, comma, DC equals internal, the 3 top-level organizational unit containers, people, engineering, and sales, and we've added 1 user, UID equals Linux CBT, to the people OU. We should find these records on both servers, on both the SUSE Enterprise 10 primary LDAP server, Linux CBT SUSE 2, and on the Red Hat Enterprise 5 system, Linux CBT Serv 4. And again, the utility that helps us to find information is LDAP Search. So task: use LDAP Search to confirm the existence of records on both systems. And we'll specify our command between the single quotes, which means do not include the single quotes in your search. Now we can perform the search from the local and or remote systems so long as we indicate the target LDAP server on the command line using the -H host option. Let's check our history for LDAP Search to see where it exists, under which user, and once we've found an instance of it, then we'll be able to execute it. If not, we'll construct the command from scratch, but there are multiple instances. So here's a generic search: LDAP Search for any object class on the server. Let's paste this in, and just to recap, LDAP Search with simple authentication, that's the lowercase x option, followed by B to indicate the branch of the tree, the directory information tree that's to be searched, followed by the specification of an object class. In this case, an asterisk simply means any object class. This is equivalent to a wildcard search. Now, it's a good idea whenever specifying base DNs or any LDAP attribute to include the attribute or attributes between double quotes. In this case, we've indicated DC equals Linux CBT, comma, DC equals internal. This is a multi-attribute of DC domain container, and object class equals star. Let's copy this into memory and navigate to the shell. And you don't need to be root to execute the search. You simply need to be able to connect to the LDAP server anonymously. Let's confirm that LDAP is up and running. And we see multiple LDAP instances or items in the process list which include LDAP in their name, but we're interested primarily in slapd and slurpd. Slurpd being the replication utility, and slapd being the LDAP server. Additionally, rc LDAP, and we need to do this as root, status will tell us if it's running. In this case, we see that it's not running on the local system. It needs to be running on the remote system. So we executed PSEF against the wrong system. That's what happens when you're in multiple shell windows. You sometimes run the command on an incorrect system. So let's SSH to the remote system. This is the first time we're using the short name. And then rerun psef grep, where we see slapd and slurpd both running. That means the system's up and running. Now, as far as the search is concerned, we'll Control-Shift-V, and this will enumerate the contents of the directory information tree. And we can analyze this in gedit if we'd like. Let's just copy the dump and paste it so we can talk about it briefly, and then compare and contrast this dump to what we witness on the secondary server. This was an add of a user. We'll leave that there temporarily so that when we add another user to the first branch, we can simply modify the user's name. So here's the dump. Any line which begins with a hash mark is a comment, and LDAP defaults to dumping information whether to standard out or to a file regardless of utility using the LDIF format. That's important to note because what that means is what you see on the screen or in a file can be imported by and large verbatim, which means this is the standard LDIF format expected for imports by LDAP. With that said, we see commented items, we see the type of search that was performed against the LDAP version 3 server. We wanted or requested all objects from the server, and here is the information pertaining to the first object that defines the Linux cbt.internal base DN or base distinguish node, which is basically a domain container or a DC. So the distinguish name in this case is, as we expect, DC Linux CBT DC internal. It is a domain container, object class, DC object, object class organizational unit. It inherits its fields or attributes from 2 object classes. There's no limit to 2, and there's no definition that says an object must be 2. Whatever attributes are required to define your object is what you will use to define that object. In the case of a domain container, it requires 2 object classes. The next object is an organizational unit. How do we know? Well, just like looking at the fields in a database, we see that object class represents organizational unit. We also see that it is an OU as opposed to a DC. So its type tells us, its object class tells us that, or its class tells us that the object is an organizational unit. The distinguish name or DN attribute tells us its full path in the hierarchy. It is 1 level below the root. OU equals people, DC equals Linux CBT, DC equals internal, and its short name is simply people, just like the short name for the domain is simply the first name, Linux CBT. Moving on, we see yet another OU, and we can pair these up with what we see in the graphic by navigating to the graphic. So we've discussed the base directory container, the people OU. We're now looking at the engineering OU, and then we'll see the sales OU. So this is the engineering OU. It resembles the definition of the people OU. So keep that in mind as you look to script or populate your directory information tree on a mass scale, perhaps from 1 or more text files, defining the objects within your directory information tree. This is the sort of syntax you will follow to create distinct types of objects. Now, primarily, when you're setting up a directory information tree, you are tasked initially with creating organizational unit containers, such as the base DC or the root DN, the base DN that is, and various other organizational unit containers. Remember, organizational units are simply containers, whether using Microsoft's Active Directory, where you see the user's OU, or Sun's directory server, or Red Hat's directory server, or even Novell's directory server, or simply OpenLDAP, on which they're all based. An OU is a container for other objects, including other OUs and or users groups and other supported object types, which are of course tied to schemas. Here's the sales OU definition, and it should come as no surprise the attributes mirror that of engineering and people. And the last object is the definition of the first user beneath the people OU, and that user's name is linuxcbt1. And the last name of the user, the surname is user. The user has an email address. We could add multiple email addresses. We'll look at that later on as we modify the objects in the directory. And at the end of each LDAP search, we see what has been returned, what was searched, what was returned, whether or not the search was successful. In this case, it was. The number of entries discovered, and we can count them from the top. The base DN, followed by 3 organizational units, followed by 1 user, totals 5 entries. So this is what we see when we dump. Now what we'll do is connect to the secondary, which is the point of this task, and dump similarly. So here we are on the primary linuxcbt SUSE 2. Let's find a window where we're connected to the secondary server. Here it is. This is the Red Hat box. We can cat etc Red Hat release, and it tells us it's 5.3, which is the current latest based on the major enterprise version 5. And let's psef grep LDAP, where we see it's up and running. And it has a default -h host of LDAP queries for non-encrypted connections, and it runs as the user LDAP. So with that said, we should be able to query this system as well. Now let's find our LDAP search command from linuxcbt SUSE 2 and copy it into memory and query this host, the secondary host, and we should see similar results. And this is the wrong host. This is the right window here. So here is a search, and it should come as no surprise. The result is successful because the server is running, and 5 entries were located. And if we quickly peruse, we see the base DN followed by 3 organizational units, people, engineering, and sales, followed by the one and only user, linuxcbt1. So both are returning what we expect. Now, insofar as querying across the wire, you simply indicate the -h option. If you execute LDAP search with --help, you'll see -h allows you to specify a remote system. So -h from, let's say, linuxcbt SUSE 2 to the host linuxcbt serve 4, which is the secondary host, and notice across the wire the results are returned. And to prove that it is indeed going across the wire, let's stop the LDAP service on the remote system using service LDAP stop. Exit status returns cleanly, telling us it's stopped, and then we will try the query again. Notice, can't contact LDAP server. But if we try to query our local system, either by using the -h option or by omitting the -h option altogether, we'll see that it works. Let's try it with simply including the -h option, and there's the dump. Let's also try it by omitting, and there's the dump. Let's try remote against linuxcbt serve 4 again. It fails. Let's try it with the fqdn, and this too will fail. Now let's restart the LDAP service and then re-execute the query, and momentarily it'll connect, and maybe the fqdn is not resolving. Let's try the short name, and that's working as expected. So we need to check our fqdn. Let's try to ping linuxcbt serve4.linuxcbt.internal. This is important that we fix this at this point, because we run the risk of referencing the fqdn and having it fail for some critical process, such as replication via slurpd or just connectivity manually. So let's modify etc hosts, as this is where the problem should be. And here we see a misspelling. Instead of Linux, it's LIU, so let's add that N. Changes made to the hosts file on any Unix or Linux system take effect immediately, so when we re-execute the query with the fqdn, we see it works. No need to restart any services or clear any caches. So with that said, both servers have the information. Now, once we've configured the Solaris server and confirmed that it too has a copy of the current directory information tree, we'll then move on to the online tool LDAP add to continue building our directory information tree and slowly but surely watch the replication take effect across the wire to the two replication partners. So let's close out these two text documents. No need to save them. These are just temporary dumps, or this particular document. We'll save this document for now. It'll help us to recreate or to create additional users in the directory information tree. So we've confirmed the existence. Let's just add one variation on this, and that is the -h option followed by hostname, which allowed us to query based on either short or FQDN. So we know the records exist. Now, what is entailed in setting up OpenLDAP on a Solaris system? We're using Solaris 10, and since this is towards the end of 2008, we're using the latest Solaris 10. It's 10.08, but Solaris 10 has been the same for a number of years now. So if you follow the steps we outline, which is to use the OpenLDAP packages available online from sunfreeware.com, regardless of the version you're executing or running, you should not have any trouble setting up and configuring OpenLDAP on Solaris. But there are a number of steps as expected. So we need to first download and then install. In the interest of saving time, we've already downloaded the key packages, so we'll just walk you through the installation. So in this section, we'll configure OpenLDAP on Solaris 10. So task 1, download and install required packages. From sunfreeware.com. Sunfreeware.com is probably the best site to find open source packages for Solaris, pretty much any version in the wild, 10, 9, 8, etc. We use it extensively whenever administering Solaris systems. So just to show you quickly, if you're unfamiliar with this website, where you can download the requisite packages. So this is the site. Now over on the right, you select your version of Solaris and platform. We currently have Solaris 10 x86 installed, so we'll navigate to this node, x86 Solaris 10. And then what appears on the right is a list of packages maintained by sunfreeware.com for the given hardware, platform, and software version. If you navigate down this list towards the section that begins with O, you'll see OpenLDAP. When you click on OpenLDAP, it is or appears in focus towards the top of the middle section, and all of the required packages or dependencies are listed, are included. This is the main package, OpenLDAP. When you hover over the link in the status section of the web browser, you see the gzip package that can be downloaded. You can copy this link location into wget and download it using wget, or just click on it with the web browser and it'll pop up asking you where you'd like to save it. But we've already downloaded it, so we won't download it. Ditto for the remaining dependencies. If you need to fulfill dependencies, for example, such as OpenSSL, click on OpenSSL where you'll see OpenSSL's package, and if there are any requirements for OpenSSL dependencies that you need to fulfill, do so. A stock Solaris 10 system, which includes the development or core, includes most of the things needed for you to install these requirements or these dependencies. But to be on the safe side, we suggest that you download the dependencies listed on sunfreeware.com, simply because although you may already have similar packages like OpenSSL, SASL, DB42, the Berkeley DB installed on your system, as well as libgcc, they may be located in directories that OpenLDAP compiled by sunfreeware.com doesn't expect. So use the packages on this site to avoid any problems referencing the libraries, which means you'll have to maintain 2 copies, but it's not a big deal. If you insist on using the packages included with the Solaris build, then you may need to recompile OpenLDAP by downloading the source, pointing the OpenLDAP package to the appropriate directories, or create symbolic links to compensate. So with that said, let's connect to our Solaris server. Now back to the graphic for a moment. If you recall, we mentioned that the Solaris 10 server, this box here, is located at 192.168.75.150. So we'll SSH into it. Its name is Linux CBT Sun 1. It sits on the domain linuxcbt.internal DNS-wise, and it's running Solaris 10, 10.08, and we will configure it to be an LDAP slave server. So let's find a shell, a clean or free shell. Control-Shift-T will do the trick, and we'll SSH as root to the host's address. Now, we could take the step here of updating etc hosts, because at some point we'll need to ensure that the host file is updated, at least on the primary DNS server. Or we can use DNS. Now, we've set up DNS on the portal system that we're using to include a record. Let's try to ping it. For resolution purposes, and it resolves. The short name doesn't resolve, however, but the long name does. So if we try to ping Linux CBT Sun 1, indeed it responds, perhaps because we've updated already the etc hosts file. Let's grep from etc hosts, and it's not, so it's taking off because of the search domain. So we can connect using the short name as well as the long name, because the search domain, if we cat etc resolve.conf, for example, we see that the search domain is linuxcbt.internal, which means we can specify a short name, and the DNS client resolver tacks on the suffix. So with that said, let's SSH as root to linuxcbt Sun 1 using the short name for convenience. We're prompted to accept the public key of the SSH server running on the Solaris box. We'll have to authenticate, of course, for now using password authentication. And we've already configured our shell to use the bash shell as opposed to the Bourne shell. This adds or allows for the flexibilities provided by the bash shell on Linux. So the same experience that you've come to enjoy on Linux, you can enjoy in Solaris by simply referencing the bash shell. We haven't fully tailored the shell to echo the path, the current user, and so on, but that's all miscellaneous. So with that said, we are on the remote system, and notice it reads generic January 2005. That's the kernel version, although we are running a 2008 version of Solaris 10. Solaris doesn't change as often as other operating systems, so the same kernel from 2005, which constitutes Solaris 10, is still in use, with of course security patches applied and the like. But basically things move much, much slower when it comes to Solaris and enterprise products like Red Hat Enterprise, Solaris 10, etc., for the sake of satisfying customers in various sectors. So with that said, we're on this remote system. Now we've created a temp subdirectory beneath root's home directory, which happens to be the root of the file system in Solaris, as opposed to /root as you have in Linux. And beneath temp, we've created an LDAP subdirectory. That LDAP subdirectory contains the prerequisites, the dependencies, including the Berkeley DB, OpenLDAP itself, OpenSSL, and SASL, which allows LDAP to do its encryption magic. These packages need to be installed. Now we've already unzipped each of the packages, which is why they no longer have GZ suffixes. So with that said, we're going to use package add to install each of these packages. So let's go ahead and install each of the packages. In Solaris, we use the package add command to install a package. If the package is located in a directory, we use the -d option followed by the name of the file, optionally prefixing it with the full path to the file. Let's install them as we see them. Minus OpenLDAP will install OpenLDAP last because the other three packages are dependencies. This will install the DB, Berkeley DB. We're prompted to accept, and this will set up the Berkeley DB. Now, generally, packages installed from Sun Freeware are installed beneath user local, followed by the package name. We will find that that's the same with OpenLDAP, so beneath user local we'll find all of the files and directories needed to operate OpenLDAP. Berkeley DB was installed successfully. Let's move forward with OpenSSL. And while that installs, we'll just note that we use package add -d followed by package name. And we'll just include that it's g-unzipped. OpenSSL has been installed. Let's install the final dependency. This is SASL, which again installs beneath user local. And last but not least, let's install OpenLDAP. This is version 2.4.11. It implements version 3 of the LDAP protocol. One note regarding this version, which is a relatively recent version of OpenLDAP, it does not include slurpd. slurpd is being deprecated, although we're setting up replication based on it. We're doing it because you're likely to find slurpd out in the wild for years to come, despite the fact that it's being deprecated. It's being deprecated in favor of the sync REPL process, which we'll look at later on, which allows replication to occur much more reliably than slurpd. So let's just note slurpd is currently being deprecated, but you should still understand how to configure it, which is why we're going through this process. Let's take a look. LDAP has been set up in user local. Beneath user local, we'll find a bunch of directories. Let's navigate there. And here we see one for Berkeley DB. There's a bin directory which contains various programs such as the LDAP online clients and others. We've installed ncurses and nano so that we can have our favorite editor. There's a doc subdirectory for each package installed from Sun Freeware. A documentation directory is created beneath user local doc. There's an etc subdirectory which contains configuration files beneath OpenLDAP for OpenLDAP. This is the equivalent of /etc OpenLDAP on both Red Hat and SUSE Linuxes. So here we see the client ldap.conf, some schema files, a schema directory, and the all-important slapd.conf. This is what we will update. So let's just also note that config files are located beneath user local etc OpenLDAP. This is the top of the tree, the hierarchy, in contrast to etc OpenLDAP in Linux. In addition to etc, we've got an include subdirectory which has include files for various modules, a lib subdirectory which contains libraries that are needed to operate nano as well as OpenLDAP and its dependencies, and those library files generally end in SO in Unix and Linux environments. there's a libexec directory. Libexec contains executables that pertain to slapd. In this case, there's one executable instead of two. So we don't see slapd and slurpd, just slapd. Now, the absence of slurpd does not mean that the OpenLDAP implemented in Solaris will not accept updates from slurpd on other systems. It certainly will. It just you will be unable to configure this particular distribution of OpenLDAP to replicate outbound to other systems because there is no slurpd, but you will be able to with syncrepl. So you cannot use slurpd on Solaris to replicate outbound, but you can receive replication updates from other systems configured with slurpd. So libexec contains the slapd program. So note, slapd is located in user local libexec, as we've just indicated. The man directory contains man pages. sbin contains symbolic links for running different programs such as slapadd, slapauth, etc. Now notice slapadd, which we have used, and slapcat are simply symbolic links to slapd, the same program used to operate the LDAP server. We also see links for SASL support. And that's the sbin directory. And there's share, SSL, and var. var is important for LDAP support. It contains the database directory for the LDAP server, as well as slurpd changes. Here are the LDAP databases we saw on both Linux systems. There's a slurp directory. Currently empty, no changes have been replicated. And then there's a run directory. The run directory contains the PID and arguments files when the system's up and running, just as we've seen on the Linux side in var run. So that is the environment. The bulk of the files that operate or constitute OpenLDAP are beneath user local and some directory or another, libexec, bin, sbin, etc. etc. for configuration files. So now that's in place, we can resume where we left off, configuring the slave and master systems in the Linux environment. We need to update the master server to replicate to this new replica. So step 2, or task 2, is to configure Solaris as a replica. And obviously multiple steps are involved. We should update slapd.conf on the master server. Let's go ahead and do so. We'll be copying the entries that define the other replica and just making some slight changes. So let's find our master server, SUSE2. And here it is. We'll navigate to etc OpenLDAP, and then modify slapd.conf. We'll navigate to the replica. We can just search for replica using Control-W, and then copy the entire block minus the rep log file. All of the replication information will be in one log file, but we do need a replica block per replica, or per replication partner. And we should simply make the changes to reflect the name of this new server. It's Sun1, same port 389 for now, we're not using encryption. Same suffix to be exported. Again, you could export a fraction of your directory information tree. Same bind DN, same credentials, same bind method, and we're currently not supporting transport layer security. So that takes care of the master slapd configuration. And we'll just note, copy replica block and rename for new server, or for new replica server. So now that we've taken care of that configuration, we do need to update the configuration on the slave. So update slapd.conf on the slave server. And we again can copy the entries we place on the Red Hat slave server and make the minor changes. So copy changes from existing replica server and modify to match the Solaris system. Let's find a window where we have the replica open, Linux CBT Serv 4. We'll then navigate to etc open LDAP. We'll modify slapd.conf, and then we'll find the section where we defined root dn, root password, update dn. Let's just search for update dn, as well as update reference. This entire block, as well as the suffix, we need all of this because the default suffix will not work in this particular case because it's different. And now we'll navigate to etc, open LDAP, and we'll do as we've done before. We'll copy the existing slapd.conf to a backup, although there is a default version of it. Slapd.conf, the slapd.conf.back 1, just to have it, and the -v isn't taken. This isn't Linux, so it doesn't take it. Then we'll nano slapd.conf, and we'll find where root dn is defined. There is a default root dn, and here is the suffix. We'll just comment this all out because this is the default, including the root password. All of this needs to be commented out. These are all defaults. And then beneath all of this, we'll make some space and define our settings. So here's the new suffix, and we'll just label this area replication of DC equals Linux CBT, DC equals internal from Linux CBT SUSE2.linuxcbt.internal, so that when we look back at this months from now, we can recall what we did and why we did it. So we've got the manager, the root DN, the root password, the update DN, as well as the update reference if a client attempts to make a change on this particular system. We can save these changes. And by the way, if we grep db from slapd.conf, you'll see that the directory, the database type that is bdb. The directory, however, for storing the database is beneath user local. That's less slapd.conf, just to illustrate the point. We see the PID and argument files are located beneath user local var run as slapd-pid as well as slapd.args. Everything's relative to user local when you install a package from the Sun freeware site, as it expects to find everything beneath user local. So the environment's already tailored to be beneath user local. And the directory where the database files will be maintained is user local var open ldap -data, which we showed you recently, and there's also a slurp directory for slurp changes. So we've updated slapd.conf, and it now reflects the new settings. Let's also update etc hosts on Solaris system to be able to find at least the master LDAP server. Now, if DNS is properly configured, which we've set up, this shouldn't be a problem. Let's cat etc resolve conf on the Solaris box. Notice the name server is the IP address of Linux CBT SUSE1. Let's take a look at our graphic. That's the .50 box. This is our portal. This box is doubling as a DNS server. If we try to dig, for example, Linux CBT SUSE2, Linux CBT.internal, it will default to that DNS server. But notice, no result. It doesn't have a record for it. So to avoid any DNS concerns, let's simply nano etc hosts so we can update DNS later. And we'll include an entry for Linux CBT SUSE2, which we can double check from the window. Always check your IP addresses before you go configuring. If config will tell us what it is, and it's .19. So back to the hosts file. and this should do the trick. Now from the shell, if we attempt to ping Linux CBT SUSE2, it resolves. Let's try it using the FQDN. Because again, however you reference these names in your configuration files will be how the DNS client tries to locate the particular host in the background. So we want to be sure that everything's properly configured. So DNS or host resolution for the key host is in place. We've made that change, and now we're pretty much almost ready to wrap up this configuration. So we need to dump the current database, which has not changed since we dumped it the first time, but we can dump it again using slapcat. So let's find our section where we have slapcat. We'll search this document. It should be slapcat-b, and we'll just copy this block. And then we'll use slapadd when we're done to import it. So step D, export current DIT using slapcat. This will create a file, naming it what you see, and we do this on the master as we've indicated to the right of the command. The master is Linux CBT SUSE2, so let's find it. There it is. Again, hostname will tell us as such. We'll navigate to our home directory, LDAP, where there is a copy of it, but nonetheless we'll run it again. And there's the existing copy. But this copy is about a day old. Now remember, when you execute slapcat, you need to have the server off. We need to turn it off. So let's RC before we neglect that step. RC LDAP stop. Now we've got the Linux cbt.internal.ldiff file. Let's just note that. Note, stop LDAP server first before using the offline tools. The next step is to copy and import. So we'll just make it one step. Import DIT on Solaris system, which means, of course, scp.ldiff to Linux CBT sun1 into a directory named LDAP or temp. Since we have a temp directory, well, to be consistent, we'll make it LDAP off of the root, which means we need to create that directory on the Solaris box. So we'll make directory LDAP. We're doing it at the root because the root of the file system is root's home directory in Solaris. Doesn't know Linux CBT sun1. Let's update the hosts file. We'll just Control K to cut and then paste it twice with Control V. Its IP is 150 and its name is sun1. And let's retry that from the shell. Now it knows and it asks us to accept the public key and to authenticate. And now the file's been copied. The exit status of SSH should be clean. It is. And on the Solaris box, if we navigate to LDAP, we should see as such. And there's the file. Again, the file is simply a text file. It's an LDIF file. If we look at it, we'll see exactly what we expect. Now notice there's some timestamps associated with the object so that when the import takes place, if the DIT already has a newer version, it will ignore that particular record. So in addition to the standard LDIF attribute definitions for organizational units and users and other types of objects, timestamp information is included when you use utilities like slapcat as well as slurpd. Very important that there's time tracking. But nonetheless, we have the file that's ready to be imported. So Let's find slapadd in our command, or in our notes file here. There it is. And we will include this as the next step. So E1, then E2. And let's place it between single quotes so that you know everything between is a command. This will import it. Now again, we need to ensure that on the Solaris box, the LDAP server is not running. A psef grep case-insensitive search for LDAP will do the trick. It's not running. Or slapd. It's not running. A netstat grep 389 will also do the trick. There is no 389 TCP. What you see here is 389.0 is a Unix socket. With that said, let's go ahead and try to import this information. And we need to be sure that we're in the LDAP directory. Now what we see here is good and bad. The first error is not a big deal. BDB is telling us that because there's no db_config file, the database will not be optimized, so the performance can be questionable. Now we can copy a db_config from one of the other LDAP servers, and that should rectify that problem. However, we do see a problem regarding line 47. Now what this tells us is if it's gotten all the way to line 47, it has imported most records, but probably not the final record. Let's take a brief look at this file. And again, 47 would be somewhere in this ballpark, which means the user was probably not imported correctly, which is fine. slurpd should take care of it, and if not, there could be a schema misconfiguration somewhere on the Solaris side, causing it to not be able to read the record. Let's take a look at what is there, however. Now, to search a database, we'll use LDAP search, but we can't search a database that's currently not running. For example, let's find an LDAP search in our history. The generic search. We'll copy it and paste it on the Solaris side and try to execute it. Whenever a host is not specified, it defaults. The LDAP clients default to the local host. To start the server, let's go ahead and indicate it. Start slapd on Solaris. We'll execute user local libexec slapd. This will run the process binding it to the default TCP port 389. It also backgrounds it for us. Let's echo the exit status. It's running. We'll psef grep slap, and it is indeed up and running. The arguments files should have been created. The argument file as well as PID file. Let's navigate to user local var run, and there are both files. We can cat slapd args. You'll see it was started with no arguments other than the call to the process, and its PID is 3108. The PID becomes important as it makes it easy to kill the process using backticks. So we'll kill slapd by using kill space backtick cat followed by the name of the file which contains its PID close backticks, and that ensures that we can kill it easily. Now back to the search. This will tell us what was omitted. Notice we see the base DN Linux CBT internal. We see the 3 organizational units, people, engineering, and sales, but we do not see the user Linux CBT 1. That tells us that there's a problem with the record as far as the LDAP implemented on Solaris is concerned. But that's not a showstopper. We can fix that as we go along. We'll first see if slurpd will replicate it, and if not, we can see what the differences are. Usually, when you have a record that isn't imported, it's because of a schema deficiency, meaning an attribute may be defined on Linux that isn't defined in the OpenLDAP included with Solaris. It could be a missing schema, could be an outdated schema, etc. So we have slapd up and running, and we need to, as our next step, start on the master server slapd and slurpd so that changes are replicated. So back to the master server for a moment. We'll rc slapd start. Let's just confirm. Let's stop everything. We'll rc slurpd stop and rc slapd start LDAP start, followed by rc slurp start. Both are now running. Excellent. So the server is back up and running, the primary, and replication will take effect. So we have our environment configured. Granted, we're missing the one user record from the Solaris system, but again, we can rectify that as we go along. The bottom line is, as we make changes now to the primary server, this system, those changes via slurpd will replicate to the Red Hat and Solaris boxes. So we've configured replication, we have OpenLDAP running on Solaris, and now we'll move on to the other items that are important to understanding how this all works. So we'll look at LDAP add next.